What we're going to do, I will tell you when you need to wear your goggles. If you don't feel like you want to wear your goggles, then leave. Okay? That's all I have to say. Yeah, I want you to record this. Only thing though,
Let's tell you when to record.
don't put it on YouTube. I mean, put it on YouTube, but don't put any goofy techno music behind it. I hate techno music. I don't want to hear it.
That's all we're going to do.
Stupid. I hate that crap. So, anyway. So, what we have here. I will not talk over everybody.
Guys, y'all need to be quiet, please.
Okay? All right. Basically, what we have here. This red fire is lithium. Whenever you add energy to any metal, right, it will give off a certain color. Do you remember why lithium gives off that red color? Because it's bouncing up. It's going to a quantum leap into a higher energy level. When it comes back down red, what about the green? Who is that? Do you remember which one it is? Copper. Right? Red. Yeah. The green is copper, orange would be sodium. All right, let's try it again. Academy water. Oh.
Pour the whole bottle in there. Probably not a good deal.
Oh, well.
Somebody's going to steal this bucket from this water before we leave.
Yeah.
It's not water. I know what it is. You have gas.
No, this one's not loud.
Gummy bear?
Yep.
We have more on.
Kitty's out of meat.
And I was like, well,
I think I'm like,
I didn't do that all day. He's been the bottle.
I used methanol instead of...
what's so funny? I was talking to Garrett.
Don't talk.
Sorry.
You have no permission to talk. All right. T. Smith. What did you eat for lunch?
A sandwich.
Okay. 2 sandwiches. So, the dude ate 2 sandwiches. I want you to think about something. Okay? So, he ate 2 sandwiches. And he is sitting there. So, sandwiches are basically glucose. There's a lot of sugar in them, right? That is a fuel. He's breathing in oxygen. If you mix oxygen and hydrocarbons, what do you get? Fire. Do you see him on fire? I'm not gonna, I was going to say something. I won't. So, no, I can't. I'm being taped. So, I would have, trust me. So, what I want you to think about is this. How long is it going to take for his body to burn through that sandwich?
8 hours.
About 8 hours, right? So for 8 hours, his body is going through combustion, okay? And then after 8 hours, if he doesn't give his body any more fuel for combustion, what's going to happen to him? He'll die eventually, not for 8 hours, but he'll eventually die. So what I'm going to do is I'm going to take the same thing. I actually have some M&Ms. I'm going to show you how the body digests this stuff, because in 8 hours, his body is going to generate so much energy, so much heat to digest that food, right? What I'm going to do is I'm going to accelerate that and digest this one M&M in about 10 seconds. The same amount of energy that it would take for you to digest this, the calories for this, probably about 30 calories. Calories are a measurement of heat. So your body has to generate 30 calories.
1 M&M?
Whatever, probably not. Maybe 5 calories. Whatever. So, 30 calories is what I said! That is true.
30 inches is up for
So, what I'm going to do is I'm going to show you how much, if you were to go and eat this, your body has to generate a certain amount of calories, right? And it's fire, basically. But it's going to happen over 8 hours. I'm going to take that same amount of energy you have to generate and do it in about 10 seconds, okay? And the way I'm going to do that is with this stuff, potassium chlorate, KClO3. Did you guys memorize that?
Yeah.
Yeah?
Wait, no, you don't like memorization.
Yeah.
Good question.
All the fire you see will be produced in your body. So burn it.
Okay. What I'm going to do is this.
Shouldn't be wearing goggles.
Yeah, put your goggles on for this.
What about you?
I'm not wearing them. Okay, what I'm going to do is this. I'm going to heat this stuff up. It's KClO3. All right? When I heat this up, KClO3, you might not be able to see that. But basically, this stuff is getting heated up. There's nowhere for it to go, so it's going to decompose. And when it decomposes, what does decomposition mean?
Splits up and
separates into small pieces. Well, this is going to separate into potassium chloride, KCl, and oxygen gas. All right? And when that happens, this KCl is going to be a liquid. It's going to be so freaking hot. It's going to be molten salt. Okay? Molten salt, and then up here in the top of the test tube is going to be pure oxygen. If I mix any sugar with pure oxygen and really hot, what's going to happen? Fire. In 10 seconds, we're going to digest this M&M, which would usually take 8 hours. So you're going to see how much energy your body has to actually generate in 10 hours to digest one of these dumb M&Ms. All right? As soon as this thing gets going. How many people are videoing?
Where's the webcam going to?
Is it actually on the web right now? Live?
No. I'll put it on Match.com.
Chemistry.com.
Oh, yeah,
30 dimensions of compatibility. Smith, goggles. All right, here we go. M&M in 10 seconds.
Hey, you know you can use a peanut for that too?
Yep. Any kind of food.
It's been more than 10 seconds.
So,
That one's like...
10 hours to digest that M&M. That was psychotic. That was laced
You
M&M.
didn't do that all day, did you?
All right, so, anyway, so that's how long it would take, and that's how much energy your body has to put out. So if Travis were to eat that thing, by the time it's digested in 8 hours, that's how much heat his body would have to generate in order to digest it. All right, now, we'll do something else. Same situation, except anybody in here ever go to a racetrack and watch dragsters, the big dragsters, the top fuel dragsters? You know what kind? They go 300 miles an hour in like 4 seconds. 4.23 seconds. 4.23. So, what they